All right, so we're back again for the 2000 Honda Accord 2.3 liter. I got my new pressure transducer in, put a new battery in my 5-volt reference box I made. So I'm just picking a cylinder, doesn't matter what cylinder I'm on. Cylinder 3, 4, channel A for my pressure transducer, channel B, 20 to 1 attenuator for when it's supposed to spark. I just got it on a 2 millisecond division time frame, that way I can zoom in. So I'm going to hit start here. My assistant, Steve-O, is going to crank it until I tell him to stop. Go ahead. Stop. All right, so I'm way zoomed in here. I just did a 2 millisecond division. What I'm going to do is zoom out now, make this wider so we can actually see what we are actually looking at here. So we'll just go right here, make this look all nice. So from nice even humps, a lot more crystal clear than that relative compression check. Here to here, 720 degrees. So magnetic field collapse, this should be on the center, and it looks off, like it's too advanced. So we're going to do our math real quick. Let me zoom in some more here. We can make our amplitude bigger and all this, you know, fancy screen work here. But what I want to look at, this is, I'm going to go to the center of this hump. Actually, what I want to do first, I want to move that out of the way. Get that out of the way for now. I want to go from the center of this guy. Right there. Damn it, almost had it. Right, that's center to, might not be able to look at it in the video until it's centered, but I'm looking straight on. It's centered. Alright. Jeez. If I like using the computer software, sometimes better because you got a mouse to actually do this. There we go. That's 596.8 milliseconds. So if we go to our calculator, 720 degrees, you know, 360 times 2 for 2 complete revolutions, divided by 596.8, divided by 596.8. So we got 1.206. We're going to times that now by, exit out of this. We're going to put this back down here. We're going to zoom over, zoom in, make this amplitude a little bit bigger, make this one a little bit bigger. So it should spark on TDC on the center of that. So I want the difference from there to the center of the compression. Looks like it's right there. 5.7 milliseconds times 5.7. Well, we got about the same thing. We're 6.8, 6.9 degrees off. So 7 degrees off on timing is what, and that's what we got with the relative compression with the relative M clamp. So about, you know, 6.9, 7 degrees off. Too advanced, and that's why it's running lean. But it's just a lot more crystal clear picture there. So now, the reason it is, and it didn't skip a tooth, it looked like, it's because this belt's, you can't really tell because our light died on us, but this belt, you don't have a light that works. This belt's excessively loose. Not that it skipped a tooth, but I can get a light in there. There you go. So, I mean, I got over 3/4 inches of play. Okay, you can pull that back. And this belt obviously is not supposed to slide back and forth like it is there. So, yeah, so we're, obviously, if you look at this, that should be, that magnetic field collapse should be on the center of that hump. This thing focuses right there, and it's off a little bit. So we need to do some, well, we need to replace the timing belt and go from there. All right, I'm going to do one other check. same thing. We got the pressure transducer hooked up, but this time, instead of off the distributor with the signal wire, when the magnetic field collapses and sparks, we're doing secondary ignition right off the plug wire. Should get the same results, maybe a little more accurate, but we're going to probably get around, you know, 6, 7, 8 degrees advanced, which I'm imagining. So we'll go back to the scope. So what I'm going to look at now is right to the center of that and the center of that, 589.3, 720 degrees divided by 589.3 is that times, I'm going to zoom in over here. So secondary ignition, it's not a very good waveform because we're not running. There's not compression gases going on. We're not doing snap throttle checks. We're looking at this tall line. That's your kV line or kilovolt line. That's your thousands of volts. That's when it's sparking. It should be sparking at TDC when it's, you know, right now. Of course, the vehicle is going to control the computer and spark at advance when it's running, but with everything disabled, it should spark at TDC, and it's before it. The second line there, that's not supposed to be there. That's only there because that would indicate that the vehicle is running lean, which obviously it is because we unplugged the injector. So we don't care about that, and it's not running. So what I'm going to look at is put my cursor in here for my spark line kV. I'm going to go where I believe the center is at. Right there. 5.2 is the difference. Times that by 5.2. 6.35 degrees. Yeah, so about what we had before. So 6, 7 degrees off. And it all depends where you get your cursors at, because I mean, we could be off a little bit here and there, but we're roughly, yeah, 6.4, 6.8, 7 degrees, we figured. The reason it's off that, if you look at the car again, we believe the belt didn't jump a tooth because we looked at it, but it's very excessively loose. This belt's really loose. This belt wants to slide off. I mean, it should not be doing that. So what we need to do is put a new timing belt in. Might as well do the water pump since it's in there. The counterbalance timing belt for the counterbalance shaft, and that'll fix our misfires, which are caused by our lean condition, which is caused by our belt being stretched and the timing too advanced. And then we'll redo these tests, and that'll be good. So that is it for now. I'm going to go ahead and do an exhaust back pressure test on this engine because it was misfiring a lot. You don't want more than 2 psi at 3,000 RPM. So got my gauge hooked up. Go ahead and start it and see where we're at. So at idle, we're at maybe hitting 1 psi. So that's good. Now I'm going to rev it to 3,000 and hold it. So it's good. Never went past 1 psi. So that tells us our catalytic converter is not plugged up, which is a good thing.